Hey, this is Joe Burnett. I wanted to talk to you a little bit about dedicated runners. I've been thinking about this project as we've been discussing it, and I thought it'd be easiest just to kind of write down a few of my ideas, like where my thoughts are at, and just kind of talk over them a little bit. Um, yeah, I thought through it a little bit, and I wanted to start with some of the use cases because there's actually a lot of different ways that dedicated runners could come together. There's a lot of different things that it could mean. So let's talk about what we might do with dedicated runners. Like one possibility is you might actually create a set of dedicated runners in the same project as a dedicated GitLab instance. This could just be like another sort of piece of GitLab dedicated, which makes a lot of sense. That's probably one of our primary use cases. But you could also like maybe make those dedicated runners in another cloud environment. Like, for example, maybe you want to use GitLab.com for the code and the instance, but maybe you want your actual jobs to run in some other project. Maybe you have some, cloud resources somewhere else. But they want them to be just for you, and you want us to host them. You want us to manage them. You don't want to actually set them up yourself. Maybe you want to set up multiple dedicated runners, like maybe even within these use cases, maybe you want some dedicated runners for your whole, dedicated instance, but also for a separate group or a specific project, maybe different architectures available. You might want to actually do this entirely disconnected from GitLab.com. Like maybe if you're an ultimate customer and you want to run all your stuff on premise, you host your own GitLab instance, maybe you want an easy way to manage your runner stack. You can have any combination of those. And then, of course, creating the runners is only the start. There's management, there's a life cycle. You have to update them, change the scaling parameters, changing the instance template, all the things that we do to manage our SaaS runners, you would do, to manage some stack or some group of dedicated runners. And of course, you would want to delete them. And of course, you may want to recover them if you accidentally deleted them. These are realistically the sorts of things that sorts of requests that we're gonna get if we have a service that spins up a stack. We're gonna want to be able to provide support for that. Something else that we can do with dedicated runners is we can actually use this, dog food it, and make it our private runners. So we can spin up a stack of dedicated runners for our GitLab org. We can use this ourselves. And for that matter, we could actually even use this to manage our shared runners, because what we're talking about here is a generalization of what we already do for SaaS runners. And so if we can dog food it, it's just one less thing for us to manage that's special. And it also helps us, refine the requirements, because I think we probably have some of the most heavy requirements in terms of scale, the way that we roll it out. I mean, we have a lot of experience with that. So we want to try to use that. We want to try to also make this dedicated runner project, this dedicated runner architecture, look as much like what we're doing right now as possible, because we know how to do it and we've figured out a lot of stuff. So, calling it dedicated runners is a little bit confusing because I was, considering that we might use it for shared runners. So instead, let's just call it a runner stack. Okay. So a runner stack is, a runner manager that has some pool of VMs that it autoscales, and it autoscales them, runs the jobs on there. As a matter of fact, really what's most important is actually that instance group. So really, like a runner stack would be the thing that's behind a fleeting plugin, okay, the actual capacity. Because we don't necessarily need to have a runner manager per stack. And I'll come to that a little bit later. So there was a lot of use cases there. There's a lot of sort of like dimensions that we could pivot on. And so I wanted to kind of think through some of the free variables and some of the dimensions that we are going to want to constrain and the ones that we're going to want to leave free. First of all, the idea of having a stack manager is pretty important. It's important that we have like some service or some sort of environment that is responsible for maintaining these stacks. This is our Uber control plane, right? This is the control plane that sets up all of this infrastructure. It probably has a UI, right? And that UI is the thing where the user goes in there and answers some questions. And it also has a backing store. Like that data is stored, the state of the stacks is stored somewhere. So those can change, right? Like maybe in the case where when you're hosting it entirely yourself, you're going to have your own GitLab instance be the UI. You're going to have your own backing store that is not common. For SaaS runners, for our product, for GitLab.com, we'll probably have one of these, okay? But it's a dimension that can change. So we'll have one UI, we'll have one backing store. The other thing is the target instance. So there's multiple GitLab instances here. So the target GitLab instance is where do you want these, what GitLab instance do you want these runners to be servicing? And that again could be a dedicated GitLab instance. It could be one on GitLab.com. It could be many different places. So you need a pointer to it, right? And you need to know what kind of runners these are going to be. Are these going to be for the project, for the group, for the whole instance? And you need to know also, along with this stack, what runner manager is going to be connected to them. Because the runner manager is going to actually register to this GitLab instance and is going to have a pointer to the actual stack, the actual job environment, in order to auto-scale and use it. So, and the third sort of set of free variables is where you want that stack to be set up. It's like, what cloud provider do you want it to be in? You need a project ID, you need or account. You're going to need to provide credentials for that. What architecture, like Mac, Windows, etc. Scaling parameters, image that you want to use, like maybe you want to provide your own AMI, or whatever. Maybe you want VM isolation, all the stuff that goes into the parameters of a GitLab runner, right? So within the runner manager, there's a runner entry. All that stuff needs to be specified by this job environment here. So when I talk about a runner stack, I'm talking about mostly this last set of variables. They vary by the target instance, where in that instance they're bound to, right? Like project, group, etc., and an ID. This will be a unique ID. It's important to have a unique ID that's not reused, because if you delete a stack, create another stack in the same place, but we want the first one back, you need to be able to identify it. So this is the ID scheme for a stack. So the service. I was mentioning that you kind of want to encapsulate all of this into a service, and it's important to have a front door for these requests, something that is able to take those use cases that I was describing and translate them into the actual infrastructure, something that is reusable. So the way I was thinking was that the backing store for this service can be just a GitLab project, right? And I'm talking about like just a bunch of Terraform files in a project. And this allows it to be stateless, right? Rather than having like a Postgres DB, kind of keep the state of the world in Terraform files the way that we do now. Like when you look at our GitLab.com infrastructure, the source of truth is the Terraform files. So the service, its responsibility is to take this user intent, this desired state, and transform that into instructions for Terraform. It's going to maintain a pool of runner managers, right, per target instance. So these runner managers are going to be registering to different instances, and they're going to be managing different managing different stacks. And so the state of that is also going to be stored in hopefully Terraform files, if we can rig it up that way. And of course, the individual stacks themselves, right, are stored per instance and per type. And then there's this assignment of managers to stacks. So as I said, I'll get into that a little bit later. So let's look at what an example store might look like. Like here, this is what where I might put our SaaS stack service. You put it in the usual spot under ops, and then put it in, runner stacks. Here's this project, and it's got, some directory structure here. These are the stacks, and these are going to be per target instance. Okay, this is like, this is our stack service, but we're reaching out and making runner stacks in different attached to different GitLab instances, right? Some dedicated, that's like this one here, that's what the URL will look like, gitlab.com. And those will also be in different environments. So all those parameters that you get from the user initially are stored in, this canonical stack definition file. We'll just take the proto and put it as a JSON here. We may have a few other pieces of data that's just for managing state, but generally like the user's intent captured here in this JSON file. And what the service does is when it stores this, it derives these files, Terraform file that's going to take, that's going to import the modules necessary to create the actual stack, put in the variables, right? Like, I want you to use this image. I want you to use this instance type. I want you to set up an auto scaling group in AWS, or I want you to set up an instance group in GCP. And then actually forget about blue-green. I kind of dropped that from the idea. I was just thinking, and also you can store the fragment of config that goes into the runner itself, right? Like what the actual parameters should be, so that it's these derived files are what will be applied to the production environment. And then in the runner manager section of this configuration, again, done by stack. We could flip it the other way too. You could do by stack and then have, stacks and managers. But these will be, this is where you're going to take all these stacks and you're going to partition them amongst, n runner managers. So each stack, each target instance is going to have some number of runner managers. Hopefully, not too many. And we may actually even we may choose to just have, all the dedicated runner managers in one pool and just take all the different stacks and just sort of distribute them amongst them, because these runner managers are really only connecting, pulling the instructions, sending commands, pulling logs, right? Like it's no problem for them to be multi-tenant. They're pretty much stateless. Well, you can't reboot them, but they don't store anything. They're not actually getting access to the actual code. So these are multi-tenant, and it's these stacks, the environment itself, the job environment, that it is going to be dedicated. So yeah, so let's walk through what this actually might look like. Like a user actually says, create me a stack, does it through GitLab. Could also do this through the gRPC service. If you're using operational tooling. Along with that request to create a stack, of course, credentials, you need to be able to access that environment, the target environment. And so those get stored in Vault. We'll retrieve those when we actually materialize the stack. You're going to take that config, like I was saying, write it along with the derived files, store that into your backing store in, for example, ops gitlab.net, and then kick off a pipeline, and that pipeline will read those files and run Terraform apply on them. And that Terraform apply is going to set up a target environment, and it's parameterized by all those things you asked for. And it's going to set up the assigned runner manager. It's going to copy that config toml fragment in there. And that that manager will reload config, it'll pick up the new runner entry, connect, etc. So you kind of want the pipeline to sort of bring this up first, because that runner manager is going to try to start, managing a stack right away. And of course, the runner manager will register to the target instance. So you're going to parameterize that config fragment with the target instance as well, and credentials. So that's kind of like how it would get created. That's how the files are applied. So yeah, there's other service actions. You want to get stacks. You want to sort of see what's there, and when you get a stack, you ask for the instance path and ID. This is meant to be kind of RESTful. You create the stack. When you call get, you get more or less the same thing back, plus any system generated IDs. Maybe you want to update the stack. Change the AMI, change the some scaling parameters. Maybe you want to sort of like reduce the number of idle instances. This sort of updates should be fairly routine. That'll turn into another set of derived files. Those files will get applied. Runner config will get changed. We'll make task scaler be able to pick up, config on the fly and then change its parameters. So like no restart necessary. And of course, deleting a stack, this will just be Terraform delete. Each one of these will probably have a separate pipeline definition that gets run for these actions. And then of course, listing the stacks is just like, okay, underneath my instance, like what are all the path and IDs for all the stacks that I have? So yeah, those are like what I envision being some of the gRPC operations. As far as supporting it goes, like one of the reasons why I like this Terraform, the way we've done things with Terraform, is like you could see what the state should be right there. Like our operations, our SREs and on our SaaS engineers are very used to using Terraform, and it's been a very good tool. You could see exactly how things are supposed to be. The state gets stored in the project. It's got good Vault integration. So since gRPC is an entry point, we can also build our own tooling over it. Like we don't necessarily need to use GitLab.com to kick off the GitLab.com shared runners. We can just operate from ops.gitlab.net, which is what we do right now. And the intent is, these shared runners will eventually just be another stack. So when we're managing these runners, we can also manage all of these other stacks that we have. We can view the state, and because it's in a GitLab repo, right? Because it's in a project, we can look at history. We can compare it. We can recover files like nothing's ever lost, right? That's configuration. The declarative configuration, and then period. Say I think we do this already for our own Terraform systems. Just run a schedule pipeline to just do a Terraform plan and just see if there's a diff, and then cut a ticket. So like if any of these environments drift from the intent, we'll just cut a ticket and be like, hey, this person, we created this stuff in their project and they deleted our auto scaling group, and we kind of need to create it again so we can decide what to do, or anything like that. So yeah, it's supportable, I think. Like I think it's it's what we're familiar with. Now, when it comes to runner managers, I was describing like how we're going to put more than one stack in a runner manager. Having one per stack is going to be really costly, because some of these stacks are going to be idle, right? You might attach a stack to a project that's only used very infrequently. So it's going to be costly. Like it's very important for us to try to be efficient about this. There was an idea that I had earlier, uplift, sort of scaling runner managers to 0. But I think we could do something much simpler and just put multiple stacks, one as a runner entry fragment in each runner manager. We'll have to have more than one runner manager because it's going to be a scalability limitation. We're going to want to be able to sort of partition that out. B, as we roll out changes, we don't want to do that globally. We want to have a small subset, right? Probably our internal runners first. And then we want to roll out, do like a multiple day rollout so that we decrease the blast radius of changes. We don't want to bring all the runners down at once. So having a, partitioned stacks is pretty important for that reason. And each one of those stacks will be registering somewhere and controlling some set of resources. Now, I mentioned like each one of these stacks is a Terraform file. It's not going to be like the whole complete definition. It's just going to be the variables. So when we develop this, as we build dedicated runners, I see us producing a canonical stack definition Terraform module. This will be either like one or more modules that are like, here's a stack for AWS, here's a stack for GCP, maybe even per architecture. I don't know. We can decide how to break it down. And these will be something that we can share. These are open source, right? Like when we say, hey, use GitLab dedicated runners, give us your credentials. Like, what are you going to do? We're going to put this stack in your project. You can see it. Like it's very transparent. And it also encourages people to contribute. Like if you can, you can easily find ways to improve the way that we do our jobs in Terraform or in AWS or whatever. You can make adjustments and make merge requests to it. So the only thing that the actual Terraform file in our backing store would be those free variables, the bindings to which template, which architecture, etc. And the other thing that I think would be open source would be that whatever changes we make to the stack service. It's possible that we'll want to actually pack more than one runner manager in a single binary, depending on like how easy it is to manage the configuration of these. Like runner manager is designed to have multiple runners in it, but it's not. I don't think we've really used it in a way where it would have 100 or 1,000. So we might want to add a layer of abstraction, take runner and just sort of have multiple runner managers in a single binary. But whatever improvements we do there, I think that it's pretty important that it be, open source, especially since this is the thing that fully self-hosted customers would be downloading and running as a service. It would be sort of a service that runs alongside GitLab and is responsible for managing the lifecycle of runners. So typical GitLab installation will now be like GitLab, Italy, Workhorse, runner stack service that's responsible for like making sure that you have runners available. Yeah, so I think it makes sense for it to be a service. Yeah, that's more or less what I've been thinking. Please, share some comments or thoughts. None of this is set in stone. I'm kind of curious if I overlooked anything or if there's some aspect of this that resonates with you. So yeah, give me some feedback. Thanks for listening. Bye.